VIPS has not always been in Azure Cloud Native. We have been on-prem with our gigantic piece of software. And we made the move some years back to Azure. We are cloud native now. This journey was definitely not easy. We invested a lot in software. We invest a lot in people, and it was definitely worth it. So I would like to share you the way we went, how we did basically, technical wise, the services we use today, how we use them, and what we basically, or how we used our services to really migrate from on-prem to Azure. But also when we have been in Azure, it was not like that we were in Azure and we were done. It's a constant moving environment that we live in today. Most of you know VIPS. You know that we started from nothing to be one of the most used payments providers in Norway. So it's obvious that we had some challenges when it comes to making our services really available at all time and for everybody. And as you know, we had downtime as well in between. Then we talk about Azure a bit. Because we moved to Azure, we have some core services I would like to introduce you and why Azure is our choice. Then I will share with you some operational tasks. So what did we actually, how did we migrate from on-prem to Azure? But also within Azure, we have done a lot of changes over the last 2 years. And I would like to share with you those changes that we did. Then we talk a bit about people because it's the people doing all this. And it's super important, I guess, that you know a bit about our mindset, what we think, and why we're doing all this. At the end, I would like to share with you some tips. That are those tips that we have learned over the last 2 or 3 years that are very important to us. Okay, let's talk about the challenges we had. Over 60% of the entire population of Norway is using VIPS today. So if you take away all those children and maybe the older ones and people that because of different reasons cannot use VIPS, you almost get the entire population that is using VIPS and paying their bills and stuff like this. And when it comes to 17th of May, the National Independence Day, it's more than doubled. And I heard numbers that are 3 times as high as well. So this is a lot of pressure on a single day or maybe on a single hour, because it's at 12 o'clock very often that people buy their ice cream and sausages, hot dogs and things like that. And in order to make our service available at all time, we need to be super agile and we need to be flexible. Our service needs to be scalable and so on. And this needs to be very fast, of course. And then we are, of course, reaching out to the youngest people, also to the oldest people. So we are getting a larger and larger user base. More people are using us, and we have also international ambitions. And this means, of course, that we need to be even more flexible and showing that we can adapt to other or changing requirements, basically. Okay, now let's talk a bit about Azure, overall Azure. What is Azure and what makes Azure great? Then dive into some of those services. So when you're in the portal and when you, for example, create a virtual machine, you can specify in which region you want to be. And in this case, it's North Europe that I've chosen, but you can choose whatever you want, basically. And when you do so, your piece of software, in this case the virtual machine, will be deployed in this region here, in Dublin basically, in this data center, in some of those buildings. Here's a card, a map, an overall map with all those Azure regions. We have 56 of those in the world. And we have also data centers, that's wrong, underwater. Microsoft is investigating if this gives some benefits. I mean, cooling wise, of course. Installation wise, I'm not sure, but they are researching, and this is a super interesting part, of course. So when we deep dive into an Azure data center now, let's take this one in the US. It's the Department of Defense in East. Let's take a look here. This is in Quincy, and this is a huge data center as well. And let's just zoom a bit here. So in this picture, we see 8 data centers. And when I spin up a virtual machine, I can spin it up somewhere. It happens automatically. Let's just assume that will spin up in this one data center here. And what happens when the data center, or if the rack where we deployed our virtual machine is not available anymore because of some failure, then it's basically gone. And this happens also on-prem, of course. But on-prem and in Azure as well, you have availability sets. That means that there's another rack where you have spin up exactly the same virtual machine once again. So this one will then take over, of course. Or they will basically, if you have both at the same time, they will sometimes go to this one and sometimes go to this one, which is of course great. And if it's going down, it goes always to the one. This is what you very often get if you have your virtual machines not in Azure, but in a different provider, maybe here in Norway as well. But what happens if the entire data center goes down? You are basically screwed. But in Azure, you can deploy your instances also in a different data center, in a different building basically, which is of course great. But this can also fail. So if the entire availability set fails, what do you do then? Microsoft has availability zones basically. So you can say that I want my virtual machine not only in one zone, but in 2 zones. That are 2 zones that are totally separate from each other. They share nothing. And the one data zone can basically explode, the other will still work. In this picture, they are quite tight, or side by side, but it can be that they are 100 meters or even more from each other. Region pairs. So what happens basically if an entire region goes down? That would be great if the service then just continues in a different region, or at least that your data are protected. When you, for example, spin up or deploy an Azure SQL database, for example, then you can say, I want it geo-redundant. So all your data will all the time be replicated to the other region. And each region has always a sister region. North Europe has West Europe, for example. So Amsterdam and Dublin, they are connected. And other regions have other regions as brothers and sisters. So in VIPS, we basically have a pretty simple infrastructure. We have our VIPS app. It's the client, but as the client, we also have the merchants that use our services, and they connect to API management. API management is a service where we store our APIs. So each service has a REST API basically, which is specified as a Swagger file. And we have hundreds of them that we have deployed to Azure API Management. Azure API Management then routes based on the service either to Azure Kubernetes services, where all where our main services run, or the core basically. I would say 90% basically. But we have also a lot of Azure functions. That means serverless that run in Azure, and APIM can also route to Azure functions. Azure API Management can basically route to whatever you want, also to on-prem services or to web apps. It's totally up to you where you would like to route your services to. And this is a good thing because you can really shuffle things around. You're really flexible. Think of that. You have all your APIs in one centralized component. I know that sounds wrong, but it's great anyway, because you can say that today I have this service in AKS, tomorrow I want serverless, and the day after I would run my services anywhere else again. And you really can do that, but you can adjust all the time the API in API management so that the services can run wherever you want. You just, as an administrator or developer that are responsible for this particular API, you can make the changes then in API management and route then to a different part of wherever your service is running, basically. Azure API Management, I told, keeps all those APIs. It has operations, that means endpoints, so get, list, and stuff like that. And you can bundle all your APIs into products. For example, we have a VIPS service where we collect all the APIs only for our VIPS app. And then we have merchant services where we collect all the APIs that are interesting for the merchants only. And the clients then can subscribe to those products. So they get a subscription key, and then they can say, or they just see then those APIs and nothing more. So they don't have access to those APIs then that are running in a different product basically, which is makes it very modular, the whole system. So now comes really the core of this presentation, and that is how we do operations in VIPS. So how are we really working with Azure? First of all, we migrated from on-prem to Azure, and we really moved our piece of software to Azure and split them up into smaller pieces, also split the storage a bit up, and then really embraced the cloud, learned the services, worked with the services like Azure Kubernetes Services, like ExpressRoute and Azure API Management, functions, and stuff like that, just to get to know those services. First of all, we didn't have Azure Kubernetes Service all the time. No, we moved first from on-prem to DCOS. DCOS is also Kubernetes, but it's unmanaged. That means that you yourself is responsible to keep it alive at all the time. In Azure, you have this control plane, and with Azure Kubernetes Service, it's a managed service. Microsoft is responsible for that one, but not in DCOS. You have to do everything on your own. This is, of course, a disadvantage if you would like to be a bit more, or like to spend your time basically with other things like managing services. So we have services, we have lots of services. And I told you about API management, where you have your Swagger files, and they represent an API also in Azure API Management. But when it comes to services, we also wanted to be able to deploy services very easy to Azure Kubernetes Service without spending too much time in learning stuff. I mean, learning is super important, of course, but as a developer, you would maybe like to spend more time in building a great payment engine or a great invoice engine than dealing with how I can deploy to Kubernetes and stuff like that. So that's why we introduced a service configuration file. A service configuration file looks like this one here. You can describe a port where your services will run. You define the context path of it. You can define replicas, so how much instances you would like to run in Azure Kubernetes Service. But you can also define resource limits and environment variables for your application and stuff like that. And this is very important, of course, for your application in order to run good and stable. So for those of you that know Helm charts or not know Helm charts are the way of how we deploy services to Kubernetes, basically. And this particular file here, this is, we call it a service configuration file, but it is basically just a values file of a Helm chart. So when you have a service that you would like to run on Kubernetes, you define in your service or in your project 2 more files. This is the Swagger YAML file, which you basically have already, which specifies your API, and your values YAML file. What you do not define is the Helm chart. The Helm chart, it comes from the outside. It's a shared resource in VIPs, and everybody uses the same Helm chart basically. So you only define a values YAML file with all your important configurations for your service. And this makes it very easy as a developer, because you know I want to run 3 instances, not 4. I know I need so much memory, and I know what port and what's the context path, but I don't really know how Helm charts works, and I don't want to know because I'm just doing it one time and not more. So now I tell that you basically don't want to know nothing, and you just want to know your application. But how do you deploy them at the end? You need pipelines. We use Azure DevOps for this purpose, and we do not create pipelines there. We generate them basically. We have a tool which we developed. It is called the Pipeliner, and the Pipeliner takes configuration files. It takes first of all the Swagger YAML and the values YAML. And from the upper side, you see you have a configuration that defines some thing that you need, some configurations. So basically, you have the name of the build pipeline, you have the information of the environment you want to deploy to, and those kind of information that are important for the Azure DevOps. And the pipeliner, that eats those configuration files and then goes against the Azure DevOps API and generates pipelines, basically based on ARM templates or JSON configuration files as well. When it comes to AKS itself and operation, we really had problems, I must admit. So how do you really update AKS, also Azure Kubernetes Service? I mean, you go into the portal and you have a checkbox there or a button where you can say, I want to have a new version. And what Azure then does is it takes node by node, or node by node basically, and takes it down, replaces, upgrades it, and starts again, and then takes the next node. And this is totally fine. But there are scenarios where it doesn't really work. And what happens then, it goes down a node, it doesn't come up again, and then you might end up in only 1 node at the end, but you need 10 nodes in production. So this is quite risky. Upgrades can fail, and you know that maybe better than me. And we used to work that way, and we had experienced downtime. Luckily, it was during the night. High risky things we tend to do, of course, during the night when everybody sleeps and nobody pays their bills. But we couldn't continue with that one. So in the middle, you have the blue-green node, new node pools. As you might know, you can spin up a completely new node pool and deploy to that node pool then. And when everything is up and running, you can basically switch. This is great, but has also a problem because you have to upgrade the control plane at first. And this can also fail. And when you do not have the control plane available because it has some error, then how can you deploy and upgrade your services? They need those control plane. So this is also a bit risky, and you need potentially involve Azure support. And this is something that we didn't like either. So in VIPS, we go on blue-green with a new cluster basically. So whenever we have to upgrade AKS or we have to make huge changes to the infrastructure, we basically spin it up totally new, an entire new infrastructure, everything new, completely new, and then use the traffic manager to basically point to the new infrastructure. So this is basically how it looks like. We start always with blue. We have app gateway. Multiple app gateways. So this is an older picture here, but you get the point. Some requests go directly to through APIM and then to AKS. Other requests go from app gateway to AKS without going to APM. But there are also a couple of other services, of course, like functions and web apps and so on that we use. Yeah, but you have on the right side then the green version. So whenever we have to upgrade AKS, we spin up an entire new infrastructure basically. And on the top, we have all those shared services like App Insights or Key Vault, storage account, stuff like that. They are just there. We don't need to create them again and again. The same is true for traffic managers. Traffic managers are our global load balancer, where we just at the end say, okay, we don't need blue anymore. We have green just provisioned with a totally new AKS in a new version. We can now switch over to a new AKS and then we are done. I mean, this sounds super easy and super simple, but it's of course not, because it's a lot of work and we put a lot of effort into this. Nobody goes into the portal and spins up an entire new VIPS infrastructure in green, for example. Everything is automated. We call this product VIPS Core Engine. We just had to find a name, so we decided to name it VIPS Core Engine. And the VIPS Core Engine is based on configuration files only. So here are two examples. One example is VNets. So we have one VC VNet, where for green and for blue basically, and we put in a lot of subnets there. So APM is in one subnet, AKS is in another subnet, and all those, and App Gateway also have their subnets, and all those subnets with their IP ranges, they are defined, specified in this YAML configuration file. The same is true for AKS. We define in the configuration file blue and green. We define the type of the VM, the size, and all those information that are important to provision AKS. But this is only the configuration file. So how does it really work? As told, we use infrastructure as code. This is super important for us. We don't want to do things manually in the portal. I mean, there are still things that we do manually, but we emphasize infrastructure as code totally. We have basic configuration files and we have environment-specific configuration files. For example, AKS in production, we use different VM sizes, of course, than in a test environment. And but all those configurations are based on base configurations as well. So those base configurations go inside a tool, a code generator basically, that we call deployer. And deployer does its magic and spits out lots of ARM templates. ARM templates that define all the resources with all its configurations that you need to create the VIPS core engine. So first you have your configurations, then the deployer generates based on those configuration files and lots of ARM templates and so on. It generates the result, the outcomes that you need to then create the resources in Azure. So you just deploy it, and then the entire infrastructure is up and running basically. Okay, so we talked about Azure, and we talked a bit about how we work with our infrastructure, but what we didn't talk about is about the people. So what did the people do? How did we work together basically? And when you look back in September 2017, we were not that many people. It was 40, 50 around. I haven't worked at VIPS then. I joined a year later, October 2018, where we were lots of more people. I guess it was around 150 people or so. And 1 year later, it was in September 2019, we were around 300. And I guess we were around 340 or so, lots of people. And so how do we really work together? We are a lot of teams, and we emphasized all the time that we would like to be autonomous. The teams really should investigate themselves, being its own little company, decide itself, and really work in an autonomous way. And the idea is, of course, great. It's a lot of fun. You, as a developer, learn a lot and can play with your ideas and do really good things. But the problem is that you have frictions between the teams. I mean, there are teams that are dependent on other teams, and we have a lot of those cases. And we realized that this is not good working at all, because from the operational perspective, people create their own resources in Azure, and they are maybe not, as an example, not tagged. So I don't know from operational perspective or security-wise perspective who created this resource and why. And it is not used for a long time, so can I delete it or not? Those kinds of information need to be in place. So we realized that autonomous teams is not the best way to go. We, even though, would like to give them power. So we say now that we empower our teams. We want to help them. We want to make them better. We want that they grow. And we had a technology strategy for not so long ago, where we came up with this picture here. So we are really investing in growing talent. That means it's super important for us that if you are interested in Azure, then you can take courses, you can make yourself better, invest in yourself, even it costs money, even it takes a lot of time, but it's super important for the development of each and everybody, and of course super great for VIPS at the end as well. We also emphasize paving roads. That means that it's good for us that it's easy to, for example, deploy services to Azure. So we are building the roads for that and for the people. Driven by data, we don't work based on assumptions. We would like always to have evidence, of course. And as I told, empowering teams, super important for us, helping the teams to be better, not letting them totally alone. Having worked now in Azure for about 3 years, and myself being part for about 2 years in VIPS, and there are some tips I would like to give you on the way. or it's maybe the tips I would give myself if we would do it all over again. So first of all, competence, super important. As we started in Azure, we knew Azure, of course, or we thought we knew. We did a lot of things. We provisioned resources and we were quite happy, but we really realized that we did things over and over again. First of all, everything manually, directly in the portal, which was fun and you can get accomplished so much. But we realized really that we needed to automate things. But you can't do that if you really don't know the services so well and you don't know how to best automate infrastructure, basically. Because there are many ways in Azure you can do provisioning of infrastructure. The next thing is empowerment. Give the people really the freedom to invest and to learn Azure. Don't just say that use this service because this service is the service we always have used and you get to the goal. Let the people invest their time in really develop themselves, give them the power, build paved roads basically also to help them move quicker, work basically together, that you get the power to do the things you would like to do. And then the very crucial thing is visibility. And with visibility, I mean here really Azure Resource Management. And when you deploy your resources in Azure, really tag everything. You must know 2-3 years later why you deployed this resource in Azure. What were the reasons for that? When can it be deleted? Who's the owner? And is it need those resources to be highly confidential? And informations like that are very important. But also you have the security center, for example, in Azure that gives you a nice overview of all the issues, security-wise issues that you have or might have in Azure, and make those information visible to each and every developer. So the developers know the status of their resources. Make it easy for them and let them know. And if they don't know, they have to learn it. Educate them. Competence is super important in Azure. So at the end, again, cloud native means really an investment in people. So what have changed? How can the people adapt? And all those informations is really important that people understand Azure very well before you really move to Azure. Otherwise, you will spend lots of money for a little value, basically. So this was the end of the talk, and I hope you learned a bit about Azure or got a bit insight about how we work in Azure and with Azure. So thank you.